So next thing we are talking about are complex numbers. When I say complex numbers, what do you guys think of? What do they have in them? They have an I, yes. So what you need to remember, an imaginary number, I squared equals -1, so that means I is the square root of a -1. So we've seen that. And when we're talking about a complex number in general, it's anything that can be written in the form a plus bi. So you have a real plus the imaginary. That is called standard form. So I'm always going to say you have to put it in standard form, a plus bi. So the real part plus the imaginary part. We also have some terms, it's not used a ton, but they may ask you to classify the complex numbers. So while when we hear complex number, we tend to think of the a plus bi, it doesn't actually have to have both parts. It could, if I just say 5, that's still a complex number. If I say 6i, that's a complex number. So we can classify them using these 3 terms. A real just means there is no imaginary part. If it is pure imaginary, then you only have an I, you don't have a real part. And non-real complex, you have a plus bi form, but b cannot be 0. So you have to have the imaginary form. Technically, 6i would still be a non-real complex because it doesn't have to have both, it just has to have the imaginary. So those are the different classifications. You'll notice, like, if it's only has the real part, or sorry, if it only has the imaginary part, like 6i, that is both a pure imaginary and a non-real complex. So there is some overlap here. You can have more than one term. So identify each of these as real, pure imaginary, or non-real complex. We're going to use all terms that apply. So 13i, is that a real number? No, because it has imaginary. Is it pure imaginary? That means only imaginary, no real part added to it. So yes, because we're not adding a real number. Is it non-real complex? Complex number that is not just real. Yeah, it is. So this one actually fits in 2 categories. Five plus I. Is that real? No. Is it pure imaginary? No. It is only non-real complex. Pi. That is a real number. There is no imaginary part there. When we are working with imaginary numbers, we have to make sure that we are pulling the I out from under the radical first. So if we have the square root of a negative, the first thing you do is take out that negative. That makes it a radical 5I. You can write the I afterwards. Some books do that. You also, I think, last year, Mrs. Keller usually had you put the I in front of the term, really just so that it doesn't look like it's under the radical. So technically it doesn't matter, either one is fine. But if you have the square root of a negative, we take out that I. Start working some out. So if I just gave you the square root of negative 1, what would that turn into? I. That is what the square root of negative 1 is defined to be. If I said the square root of negative 8, so we can think we're going to pull out that negative, and then how would you break up 8? So square root of 4 is 2, square root of negative 1 is I, and then we still have a radical 2 left. If we are multiplying with these, we have to take out the I before we multiply them together. Okay, if I said the square root of negative 9 times the square root of negative 4, that does not equal 36. When we say the square root of negative 4, what's that equal to? 2I. What's the square root of negative 9? So when you multiply those, you get 6I squared. But what is I squared? So that means 6 times negative 1, and it gives you a negative 6. So it is not the same as if you multiply them first.
We put a hard access point. Could you put that down for community service?
It's community service for the state degree, not for like.
That would count? Okay, thank you.
You're welcome.
You have
Does
those
it
pages.
count separately for each time we do it, cause like pick up and take down, cause it takes about an hour or two each time.
I would almost say that's kind of one thing.
Okay, thank you.
That's fine.
Appreciate it.
Oh, no
Sorry to
problem.
interrupt.
No problem. Okay, so if you had just multiplied them first, the two negatives would make a positive, and the square root of 36 is positive 6. So you have to take out that I before you multiply together. All right, let's try some of those. Square root of negative 6 times the square root of negative 10. So how would we write that? We could say, take out an I, so I radical 6, or radical 6I, and I radical 10. So then when you multiply them together, I times I is I squared, radical 60. Are we done? No. What's I squared? How would you break apart radical 60?
Can you forward that
So square root of 4 is 2. So we get negative 2 radical 15. Alright. B. What can I first take out on these? Okay. So we can take out an I to begin, and then we are able to reduce with the radicals as well. What happens to those two i's? They cancel. Okay, since both the 20 and the 2 are under the square root, you can actually divide those. So 20 divided by 2 is, and that's our final answer. You guys try those two. What did you get for the first one? So you take out an I radical. So we get I squared radical 49. So that's negative 1 times 7 for negative 7. This one, if you take out your I, it doesn't cancel this time, but because the 48 and 24 are both under square roots, we could divide them. We get I radical 2. So far, so good? Alright. Let's move on then. When we are doing other operations like adding and subtracting, how do we do that? We have like terms. Okay. So if I'm looking at this, 3 plus negative 2, positive 1, 5i plus 3i is 8i. Make sure you are putting a plus bi, so the real plus the imaginary when you do these. B. What do we have to do for subtracting?
You have to change that negative sign and then distribute the negative.
I know, it's just like A, adding. So you add the real, 6 plus negative 3 is 3. Add the imaginary 4i plus negative 6i is minus 2. 3 minus 2. What would we do on this one?
What's it?
Times.
Oh.
We're multiplying.
It's in there.
Okay, so just like if you were multiplying and they had x's in them, you FOIL. That's all we're doing here. So if we FOIL this, 5 times 2 is 10, plus 35i, plus 6i, plus 21i squared. If we add our like terms, we have 10 plus 41i. What would 21i squared turn into? So 21 times negative 1. So then if you add those, your final answer would be negative 11 plus 41i. Well, that means we have 2 of them. plus 12i plus 12i plus 9i squared. 24i. 9i squared would be terms 16 minus 9. 7 plus 24. Any issues with these at all? I'm gonna put a couple up for you guys to work. Our answers are kind of close, but we have a few different ones out there, so let's take a look. So the first one, if we FOIL, we get 6 plus 8i minus 9i minus 12i squared. So that's 6 minus I. Negative 12i squared would turn into positive 12. So that gives us 18 minus I for the final answer. B. We're adding, so we just add like terms. So 9 plus negative 3 is 6. Negative 4i plus 6i is plus 2i. C, it never fails. I always put something like this on the test, and I have a large group of people that miss it because they distribute the negative and then drop this sign in the middle and start FOILing. But after you take the negative through, you're just adding like terms. So 11 plus negative 4, 7 plus 6i. So if you got really big numbers there, you FOILed instead. Yes, it is actually a very, very common mistake.
See, I had it written down too, and then just want to drop it because I was the version I was from.
Yep.
It's like, yeah, I'm gonna keep doing it.
Any questions there? Let's talk about dividing. That's not quite the same as adding and subtracting, multiplying. We have a little more to do here. I's are kind of like radicals in that you don't want one on the bottom of your fraction. So think about if I want to get a radical off the bottom, what do? We multiply by it on top and bottom. So if I want to get an I off the bottom, we're going to multiply by that on top and bottom. So if I multiply the I on top and bottom, I get 3i divided by I squared. How does that help me? I squared is negative 1, so that's 3i divided by negative 1, or negative 3i. Okay. B, it's not quite the same. Okay. If I just multiply the I, don't write this down yet, but if I just multiply the I, my bottom becomes 5i minus I squared. So all it did is essentially take the I and move it to the other term. If I multiply by 5 minus I, what would you have to do with those denominators? So if I multiply by that, I get 25 minus 5i and minus 5i is minus 10i plus I squared. Did that get rid of my problem?
No.
No. We have to do what?
The reciprocal. Yeah. What she said.
We know
whatever
what
it's
we're
called.
talking about.
Okay, tell me what it would look like.
Five
Plus
plus
well,
five.
not
The conjugate, just like we do with radicals. If it's more than one term, we multiply by the conjugate.
yeah,
Conjugate, that's
where you
what-
flip it. Yeah.
So now if we FOIL,
Same thing.
we get 15 plus 3i plus 10i plus 2i squared. Bottom we get 25 minus 5i and plus 5i cancel, minus I squared. Two I squared would turn into,
Negative 2.
so 15 plus negative 2 would be 13. 3i plus 10i is 13i. 25 minus I squared. Is it?
26.
Yeah, that would be a plus 1, so we get 26. Okay, standard form a plus bi, we have to break this fraction apart. We want the real part plus the imaginary. 13 over 26 reduces to 1/2, so we have 1/2 plus 1/2 I for our final answer.
So, do you put the I on the outside if it's a fraction?
Yeah,
Okay.
I mean you can put it on the top, but technically we usually separate it out. Alright, I'm going to have you guys try one, and this will probably be our last slide of the day. You could do 9i, but you just end up reducing the 9 later. Since it's one term, all you really need is the I. So we get 5i over 9i squared. So that's 5i over negative 9, or we could write that as negative 5/9 I. This one, multiplied by the conjugate. So we're doing the conjugate of the denominator, so 4 minus 3i. If we FOIL, that gives us 16 minus 24i plus 9i squared. Bottom, we get 16 minus 9i squared. Okay, this would turn into a negative 9. So 16 minus 9 give us 7 minus 24i. Negative 9i squared is positive 9, so 16 plus 9 is 25. So you separate it, so 7 over 25 minus 24 over 25i. There's just a little more to this section, but I really don't have time to get through that today, so this is where I'm going to stop. There's a Math Excel assignment open, and we'll wrap up the section Monday, so that Math Excel won't actually be due until Tuesday morning.